This video is from Holtzman Incorporated. Holtzman is a Longmont, Colorado, USA innovation company that is dedicated to inventing solutions for reducing global warming. In this video, AI is used for voice, not for script nor for images. We believe that is still possible to arrest global warming at this point, but getting harder the longer we delay. Stopping climate change depends on political will, not luck or even innovations for that matter. Holtzman's goal is for mankind to get to a pleasant, sustainable future, with as many survivors as possible. Holtzman manufactures ideas. We produce intellectual property, including prototypes, scale models, computer simulations, and animations. We consider no planet-saving idea out of bounds. There are 3 projects under development at Holtzman currently. This project is for mobility and has a few U.S. patents granted. We all need to get around efficiently. Transportation consumes enormous resources, not just gas and diesel, but also concrete, steel, and our limited time on this earth. And transportation produces lots of CO2. Humans spend a lot of time commuting. If travel time could be made into productive work time, or relaxation time, our quality of life can go up and stress can go down. Many of us can't drive, some of us can't walk far, and we all need to stop polluting. This idea is a networked electric hybrid vehicle that can efficiently run on either rails, or on roads. Or on both at the same time. This invention captures the advantages of both road and rail transportation modes, uses renewable power, and employs technical advances in networks, AI, and electric vehicle technology. The primary application is for relatively lightweight vehicles, ranging up to bus size. For freight delivery, think of an Amazon truck. A roughly comparable project is the French SNCF Flexi development. Railroads are cheaper to build than highways and use less real estate. Steel wheels on rails have a much lower rolling resistance than rubber wheels on pavement and can use grid electricity. They can be electrified using batteries or use conducting steel tracks to provide a ground return. And grid electricity is increasingly renewable. But rails don't reach into most neighborhoods or workplaces. And they run on schedules that may not fit your schedule, or connect your starting and ending points. Railroads have a good safety record, especially compared to car travel. In the U.S., tracks are owned by the rail companies, but shared with Amtrak. U.S. rails are built for heavy freight, not for high-speed passenger service. Roads, on the other hand, are expensive to build, but roads provide flexible transportation. Cars, using low-pressure rubber tires, have a high rolling resistance, which means they consume a lot of energy per kilometer of travel. Roads use lots of real estate, and are dangerous. If you think about it, if a road is a paved surface to drive over, a road extends into your driveway and garage. On average, operating a car costs around 80 cents per mile in the U.S. Self-driving cars are late to arrive and still face hard technical challenges. Car motors are converting from gas power to electric power. This is a 1/20th scale radio-controlled prototype model car to demonstrate the concept. It was made with a 3D printer. It has 4 flat-tread road wheels and 2 dual-flange guide wheels located on the left side. It has steering, an electric battery-powered brushless motor, and servos that lift up guide wheels for road operation. It is controlled by a 3-channel RC controller, which has a first knob channel for steering, a second trigger channel for speed and direction, and the third button channel to raise or lower the guide wheels. This is the model sitting on 2 rails. The road wheel separation fits over a standard rail gauge, so the vehicle can ride on top of rails. While on the rails, a pair of dual-flange guide wheels, situated in the front and back, lower from the vehicle and grabs only one rail, keeping the car centered on the rails. While on the rails, the car's travel should normally be controlled by a network, so no driver is required. Vehicle steering is disabled while on the rail. The steel rail can provide a ground return if the vehicle is electric. Electric power can also be used to charge the vehicle's internal battery while on the rails. This is the same model on a road. While on the road, the guide wheels retract and steering is used. Manual, assisted, or self-driving modes are anticipated while on the road. Power can be supplied by batteries. Vehicles can potentially run on the road full-time, on the rail full times, or on both depending on programmed route. While on the rails, motion should be controlled by a network. If a rail vehicle is never going to be used on roads, all wheels can be made of steel. This reduces rolling resistance relative to rubber. Hybrid vehicles can even run on both a single steel rail and pavement at the same time. This is called single-track operation. Left side road wheels get support from the top of the track and right side road wheels are supported by pavement. The dual flange guide wheel is lowered and riding on the one rail. The dual flange wheel acts as a guide wheel to keep the road wheels on one side aligned with the rail. This also aligns the road wheels on the opposite side. Steering is normally disabled. This can provide the advantages of both road and rail operation, and can turn a single-track abandoned rail line into a bidirectional hybrid road. This is a line drawing from a recently issued U.S. patent. It shows retractable dual-flange guide wheels on both sides, but while traveling on rails, only guide wheels on one side are lowered. The guide wheels on the other side must be elevated. On a straight stretch of track, guide wheels on either side can be lowered. But when approaching a conventional rail switch, the guide wheels must be lowered to match the set switch position, usually straight or turnout. For road travel, all four guide wheels are raised and steering is used. When transitioning to rail travel, the vehicle aligns itself on a road-rail intersection over the rails, and then lowers its guide wheel. Cameras or sensors can be used for automatic alignment. When transitioning back to road travel, the guide wheels are lifted at a road-rail intersection. This is another line drawing from another issued U.S. patent. It illustrates a novel passive switch, where a vehicle traveling over the switch determines which way it goes, not the switch setting. This is done by which set of guide wheels is lowered on the vehicle. If the right guide wheels are lowered, it turns right. If the left guide wheels are lowered, it turns left. There are gaps in the rails that allow the dual-flange guide wheels to pass. Thus, a vehicle decides which way it wants to go by lowering the left side or right side guide wheels. They are both raised for road travel. One hybrid application is putting a single rail along the shoulders on a 4-lane highway. The rail can be made flush with the pavement, and vehicles can grab onto it under network control. Rail speed will be uniform, and vehicles wishing to make an exit simply lift their guide wheels and steer to an exit. This line drawing shows a top view of a 4-lane highway with a grass median. On the inside shoulders are places monorails. If a car wants to attach to the monorail, it tells the system to move into position and drop the car's guide wheels. At Holtzman we love cars and we love model railroads. This model was made with using a 3D printer, an ordinary G-scale track. If you want to make the model yourself, reach out to me over my website and I will be glad to supply you with stereolithography files and a bill of material. Contact me at tom@holtzmaninc.com. The electrical components are mostly imported, inexpensive and available from online vendors. In conclusion, I believe this idea should be considered for engineering discussion, analysis and test deployment. Its advantages are energy and resource efficiency, use of renewable energy, works on conventional roads and conventional rails, has low cost and safety. With advanced passive switches, the cars can navigate their own way through a network of rails. For automated mobility solutions, in addition to hardware, there is also a necessary software and networking components that will be developed. Thanks for watching.